So it's just turned the hour, so we'll start. Just like to welcome everyone. Thank you for joining us. Thank you for giving up some of your time to watch our webinar. We'll just spend the first minute just quickly going through the agenda, just looking at what the webinar is going to cover, and then we'll dive in. So basically, we're just going to discuss why. We spent a couple of minutes discussing what we're trying to achieve. Then we're going to have a quick demonstration of Sonar. We're going to look at Sonar. Then we're going to look at MB Precise running under Sonar. We'll have a look at using Sonar and Jenkins to build continuous integration, continuous code inspection, code quality gate. A fairly simple one. We'll then go through and have a look at the diagramming component of the application of the MB Precise tool. So, what are we trying to achieve? Now, lots of different people probably put different words to this, or have different thoughts about what we're trying to achieve with code quality. But for my 2 cents worth, what we're trying to achieve is writing cheap code. And when we say cheap code, we don't mean that we're going to hire the cheapest developers and we're going to give them the worst or the cheapest possible computers we can find, and find them the cheapest office block to run, and expect them to produce outcomes. What I mean when I say cheap code is we're trying to produce code which has the least cost of ownership to the business. So that means that it's easy to maintain. So making it easy to maintain means it takes less time to maintain, which means it's understandable. It performs well, so this is a combination of it's bug free and it doesn't cost the least amount of hardware to run, as is effective or convenient. It can be changed easily. So if it's the more easy it can be understood, the more easily it's going to be able to be changed. Which means the cheaper it can be changed, which means the cost of any changes is lower, and it can be tested. So the easier a piece of code can be tested, or the easier or the more testable we can write a piece of code, or the simpler we can write code, that it makes it simpler to test. That means the cheaper it's going to be to change the code. It's going to be cheaper to test the code as well. And lastly, it's going to be correct. So the more correct and more buggy the code is, applications are, the cheaper they are to the business, because things like downtime, bugs, impact to clients, they all cost money. So depending on the nature of the industry you're in, some of those bugs might be, if you're just Facebook and your Facebook page doesn't load, well, it doesn't matter really. But if you're a bank or you're insurance and you then one of your bugs moves a decimal point one way or the other, either it moves one way and it costs your customer more, and by the time they find out about it, they have to give you a call, and they have to get you to give them money back. Or the opposite way around, which won't make them happy, or the opposite way around, where you've charged your customer less, you've actually made less money because the decimal points moved the other way. Well, then you've got to deal with the situation of you've lost revenue, but then also if you go and then tell a customer that you're going to take more money off them next time, that still annoys them and potentially you lose a customer. Okay. We'll just pause there for a second just to see if anyone does have any questions. Okay, we'll keep going. So that's what we're trying to achieve with code quality, writing cheap code. Now, if we're working with other particular products, other development environments, other development languages, would have a certain number of tools that would help us. So if we're working in C#, we'd have things like Reshaper. In the Java world, which is probably where a lot of these quality tools that you can use, or that they're available that help improve the quality of your code. There's a couple of standard ones, so we're just gonna look at those to give us some context of what we're trying to achieve. So the first one we're going to talk about is we're going to quickly look at is find bugs. So find bugs is just a Java application that analyzes your code. And I think it actually analyzes your code, looks at the code and tries to identify potential places where there's bugs. So this could be things like we're using an equals, an object equivalency equals rather than a string equals, for example. It could be where you've got potentially got synchronized blocks calling other synchronized blocks. It could be where you're there's a few examples here. Could be well. There's a whole spate of them. So if you turn SonarQube on, a Java project and with find bugs installed, or where you've run find bugs, you'll find lots of different ones. The next one we're going to talk about is check style. So check style is again a Java one, and I believe there are all equivalent ones for other languages. But essentially, in the Java world, this means that it's looking at your Java code and trying to tell you whether it conforms to some sort of standard. So in this case, it could be do your ifs, if and else statements have the begin end statements, the curly brackets rather than do, or your are your variable names appropriate? So, for example, are you using all uppercase for your variable names? Are you using all uppercase for your constants? Are your variable is your code camel case? Is your code validly indented? Do you have a whole bunch? Have you written your entire function by writing it all in one line? Are your line lengths 1,000 characters? So check style addresses or helps address making the code readable and understandable. And the last tool we'll have a quick look at is something called PMD. So PMD, it's very much like find bugs. The only additional thing that PMD has is that it's got something called CPD or copy paste detection. So what PMD does, again, it looks at the code like find bug does, and tries to find a different set of potential errors. So some relate to threads, waits that notify, things like that. The other one is this copy paste detection. So what it does is it analyzes the code via tokens and tries to identify where the code is syntactically or logically similar across the whole project. And this is where it sort of comes into its own, because it's something that would be extremely difficult in a large code base for developers to identify that they've rewritten the same function that's been written previously in another place with an extremely large project. So the larger project it is, the more developers working in different time zones and potentially different countries or different parts of the codes, more likely you'll have code duplication. So PMD helps to reduce that. And by addressing where your code duplication is happening, it also helps with your overall code layout and your code architecture. So by identifying that you've got duplications occurring, you can address those, and at the same time point developers towards, say, some common library where known common functions are. Okay, so they're the quality tools that we've been looking at. And the reason we talk about those quality tools is those are the ones that synthetically we're trying to recreate with the MB Precise Sonar plugin. So we sort of label it as we label it as find bugs, check style, and PMD, but for message broker developers. So there's very similar checks or same style of checks in those three products as what we've got in MB Precise plugin. A couple more terms we're quickly going to go through just to give us a bit more understanding of the continuous integration and what we're trying to achieve, there's something called technical debt, which was coined a few years ago, and that's basically a measurement of the amount of outstanding issues in our code that we have identified, or we can identify, that would make it harder to write our code better in the future, or write cheap code in the future. So it's another analogy is if we're building a car and we really need that car right now because we need to get to work, then we might go, well, okay, well, we can live with a 3-wheeled car because it will get us to work. It doesn't work very well, and in the long term it's pretty costly, but I can have a 3-wheel car in a day, it'll get me to work, or I can have a 4-wheel car in 2 days. So I build my 3-wheel car, it gets me to work today. That's great. But then I realize, but then I've got to start taking more people because it's my car's become quite popular. So now I've got a 3-wheel car, but really to get where I need to go go back and fix up the things that I didn't do as in the way that I wanted, or didn't do in a better way, or in a clean way. And so I need to spend time, which is what technical debt is. I need to go back and spend some time and some money getting my 3-wheel car up to a 4-wheel car. Now these links are all available on the internet, but and also in the agenda you would have received when you signed up. Continuous integration is a process where previously, years ago, when applications were being built, or large applications were being built by large teams, large numbers of disparate people, what would happen is a whole bunch of people would be writing a piece of code, and a whole bunch of people, another team would be writing a bit of code, and months later they would go through an integration phase where they'd try to get those components to work together. So analogous to that might be that someone's writing the back end of the server and someone's writing the front end GUI client, and they're not putting their code together for months. So when they actually put it together, they find that the methods the front end calls don't actually return the expected data from the back end, and so they can't display the data because it's not there. So continuous integration is an agile practice where you try to integrate all your code together from your teams to make sure that A, it compiles, and B, that the contracts between the components are still effective, or the contracts between the components are doing what they need to be doing. And if not, the contracts need to be changed, and everyone's aware of the change in requirements. So continuous integration usually involves something like a build server, and some sort of automated regression testing, ideally. So that way you can write some code, you can compile it with everyone else's code in a common way. You can build it on a build server, so that means you're getting a continuous, you're getting a repeatable build, and then you can run some tests, and then you can know that the business logic is actually being achieved. And the last one we're talking about quickly is, before we get into demonstrating Sonar, is continuous delivery. So continuous delivery is really an extension of continuous integration and continuous code inspection. So continuous delivery is where we try to leave our software in a state, or the developers are trying to achieve a state for the software where the code is always potentially deployable to a customer or to an environment. So what this means is the code that we build code components in small I guess digestible chunks, or we build features in smaller chunks that by themselves complete, and can be potentially given to a customer, whether or not they make any sense in a logical or business sense, because they may have other features that are required. But so any point in time, the software potentially could be released to a customer for ideally some sort of validation or acceptance testing. So this leads us to a cycle of a developer makes a change. You have some sort of continuous integration. So that the code, we know the code change works with other existing code and other developers' code that's going on. We have a build server that may run some automatic test, and then we have some sort of automatic deployment into, say, a development environment for the business to look at. So you get a very short, or ideally a short turnaround in between when a code goes in and when a business person can look at the code and decide whether or not it does what they require or completes the feature or solves their business problem. That way you can get better communication between developers and testers and the business, and also means that you're potentially giving more value to the business because you can release software more often. And the last term is Snowflake setups, which is again a Martin Fowler one. And basically, a Snowflake setup is a setup where you can't guarantee that you can repeat it. So ideally, we don't want to have any Snowflake builds or Snowflake servers. Hence, there are some checks in our MB Precise that tries to ensure that our builds are complete, or their components are all complete, and all the configuration necessary is there, so that something that is running on the developer machine, once checked in and passes all our checks, should run fine in any environment, because the developer's done all the steps they need to do as far as build scripts and test scripts and SQL scripts and configuration files. So we'll just pause there for a second before we get into the actual Cerner demonstration. Oops. Okay, so I'm just going to jump over to Cerner itself. So Cerner itself has two components, or three components really. One is a database that captures that the Sonar engine captures and stores metrics into, metrics violations it records it into with a summary of what the code looked like at the time, and some information around the code itself. So the metrics and violations, we'll get into those in a second, and then a GUI. So as I said, Cerner collects or builds two things mainly: metrics and three things: metrics, violations, and copy paste duplications. So how it does this is, depending on the language you're doing, it will use existing analyzers, and it will actually augment the data from different analyzers together to give you a complete quality picture. So if you're looking at Java, it will run find bugs and check styles, PMD, and any other checks you may have as part of your build. Then it will take the outputs of those and then store the outputs of all those different checks together into one snapshot of the quality of the code at that time. In the case of the message broker plugin, there's just the message broker plugin, which analyzes the message broker code and stores the quality information. So that quality information we're looking at is split into three: metrics, which is on the widget here in the top left, which we'll quickly look at; duplications, which is here, which is basically a summary of how much code duplications and issues or violations, which is the thing that we're usually most interested in. But we'll quickly look at metrics first. So metrics is just a summary of useful information about the project, or hopefully useful information about the projects, which could, which by itself may not mean that there's that you're following good practices or bad practices, or there's good code or bad code, but it can help to identify, or it can help you look in the right place. There's some standard metrics like lines and files, and there's some specific ones for message broker. So the number of nodes, the number of SOAP nodes, the number of RCD nodes, and flow length and complexity. So nodes is interesting because it gives us a summary of the actual size of a flow. So being a big flow doesn't necessarily mean it's bad, but being a big flow potentially. So we'll go to request with aggregate message flow. Has 23 nodes, and if we look here, request with aggregate message flow, this is what it looks like. So we can say it's quite complicated. So we can, as architects or developers, we can look through the metrics and look at any unusual or unexpected values for these, drill down into the flow or the SQL or the map or the Java code or whatever that's recorded against, and have a look and see if it does require our attention. So in this case, we might decide this may or may not be important. So if this particular flow is called once every week, we might be able to live with the big size. If this particular flow was called thousands or tens of thousands times a day, we might decide that this might require some refactoring for the sake of performance. So here we've got then we've got RCD nodes. So these are one of these nodes that people are warned that can lead to performance issues. So we might want to keep track of how many the developers are using. So if it's a fairly constant amount, then we wouldn't be concerned. But if we suddenly saw an increase or a steady increase in the number of these nodes being used, we might want to have a look at where these additional usages are coming from, and or look at whether or not there might be alternatives. Flow length again is one of those performance measures or potential. It could be leading a measure that could indicate a potential performance issue. So this is saying what's the longest path through any particular flow. So we're looking here, it's backlog 6 long flows. So if we look at backlog 6 long flows here, we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a potential path through the code of 10 nodes, which again, if this flow is only used once a week, then it's maybe not an issue. But if this is one of our major flows that's part of our mandatory processing, it's run 10,000 times a day, then we might want to look at this and say this is somewhere we might want to refactor our code to improve the quality of our business outcome and potentially increase our performance and throughput. But again, just the fact that it's long isn't per se a good thing or a bad thing, but it gives us an idea of where we need to look. The next two are interrelated. There's two more relating to something called psychometric complexity, which is a measure of the pass-through code. So we can look here at the psychometric complexity of a file. So this is saying how many potential paths there are through the code. So if we look at this SQL file, we can see that we've got a begin, which basically counts as the complexity of one, say there's one pass for the code. But then here we can see we've got a while condition, which is the second path. So it may or may not be entered. And you've got within that while condition, we've got an if condition. Within that if condition, we've got another condition. So here we can see that the number of potential paths through our code and the potential paths we really need to test is increasing. And so we can see that this is quite a complex piece of. There's quite a number of permutations we'd need to test to be comfortable around this code. So this is just give you some understanding of what's our most complex piece of code. Then there's two more. They've also got the same thing for the psychometric complexity of a map, which gives an indication of how complex a mapping step is. So we'll look here. This is our most complicated one. And we can see here that there's a loop. There's a for each loop there. Within the for each loop, we've got So we've got a for each loop, another for each loop, and within this loop we've got a condition. Within the condition we've got another test, and then another potential path through the different conditions. So we can see here there's an else condition. So we can see here that there's lots of different ways that the map, different paths through the map to execute for a mapping step, which again could indicate that we might want to throw more of our testing effort at that particular process where that map's used, just to make sure that we've tested the necessary paths to get the expected outcome. So the last two are again performance related. There's something called string manipulation load and weighted string manipulation load. So string manipulation load is basically a count of the number of string functions within a piece of SQL. And the weighted string manipulation load is a count of the number of string manipulations, but also trying to take into account where they are. So the deeper they are, or the more nested they are in, say, a while loop or a for loop, it's more likely the more likely it is to be called a number of times. So the string manipulation load indicates that just the particular SQL function is doing a lot of string manipulation. The second one is to take into account where, if it's running through an iterative loop, where you might see a performance hit as your either results get larger or your message gets bigger than it's passing. So that's metrics. I'll just pause for a second to see if there are any questions. I will keep going. So we mentioned CPD and duplications. So this here is just a summary of the code duplication it found. So this needs to be read with with a grain of salt, because not taken with a grain of salt, because there is a certain amount of duplication that's occurring in message broker code just by the nature of the way the copy message headers and copy entire message code is added to SQL. So a 5-line duplication may occur all over the place because just the nature of the way the SQL is written. But in this case here, we can see there's some things that are larger than 5. So a 5-line may or may not be important, but there's some things that are larger than 5. So we can see here this one's got 83 lines of duplication. We see also another one with 83 lines of duplication. And what we're saying is that this has identified these two pieces of code as duplicates. There might be some more subtle ones. So here we've got 21 lines of duplication. Which is our copy message headers, which you, as I said, need to look at for in the context of what message broker code does. So again, here there's a whole bunch of duplications to do with just being message broker code. Let's just see if we can find another one, an unexpected one. Okay, I'll try something here, 69. Okay, so we're saying this thing here is basically duplicate other functions. Okay, so that's duplications. Okay, we'll go through and have a look at the violations. Now, violations are essentially the checks that the code, the component, the plugin is doing. So if we go into quality profiles, we'll see here we'll be able to list all the violations. And so what we can do is we can create what we call a quality profile, and that's where we add or enable or disable violations depending on what we think is important. And this is also where we set the the priority of those violations depending on what we think is or isn't important. So if we have a large old code base, we might decide that an unused or unreferenced variable is the end of the world, but we wouldn't want to know about it because we're not likely to be fixing them all because that's too much regression work. But if we had a new application development, or we're doing new code, then we might decide that an unused variable is something that we do want to get rid of early. So we might make it a higher priority in a new project. So we'll just bring up all the rules. We'll just quickly talk about a few of them. We'll just sort of pick a few. So a standard sort of a check style type check of multiple statements on the same line. So we've got a whole bunch of logic in one line. It makes the line longer than it needs to be, and makes the line confusing, and makes it a bit more difficult to understand how to what the code's doing. Looking at deprecated usage of the XML-NS or XML-NSC parser. So this is saying we should prefer using the more up-to-date one, the XML-NSC parser. Module names, so again a coding style, module names, logic style, negative if conditions. So this is where we're saying we've got an if with virtually nothing in it, and an else condition that contains most of our logic. So, or with a not condition. So what we might want to do is flip the order of our if condition around, so the if condition makes a bit more sense. Not all input nodes are connected, so this indicates that you might be using a file node, but you're not sending it a file, so you're not going to get any valid response out of that. Queue names and queue definition checks. Performance issue, you've got sleep being called, which is unusual, but doesn't necessarily mean it's bad, but could be a potential issue. Logic issue where the compute mode is set to message to say, right, you're writing a message, but you've never actually you're not actually accessing the message within the code. You're trying to update a message from a filter node, which it won't tell you can't do it. It just means it doesn't make any sense, and it actually won't have any effect. So if you're changing logic, then if you think you're writing logic in a filter node, you're actually not, and it's not doing anything. Filter node may not have connections connected correctly. So what that's saying is you might have 3 paths through the filter node, or 3 paths through the filter node in the code, but only 2 output nodes. 2 outputs from the node, so they don't logically line up with the code. Filter node may only have one return value, so a filter node that only returns one thing could either be just a compute node, or could be deleted because it might just be unnecessary. Coding standard, the function of procedure is longer than the standard threshold. Most standard thresholds can be configured within the configuration or property file for SonarQube when you run the analysis. So you've got complexity threshold, function size, line length, and parameter length. The timeout in seconds is to do with the way that the MQ gets and the HTTP reads when they're going outside of broker, how the minimum or the maximum amount of timeout that those things are allowed to have before having exceptions. So it's something you can be wary of. Because you've got a usual processing of a few seconds, but you've got a node that times out after 2 minutes, then that node might cause performance issues if it's not performing correctly. So there's a lot of different checks that we do run. So if we go into Message Broker and go into SonarQube and we actually look at some of these issues, and we can pick a file, and it'll if we pick one of our issues or jump into a file, oops. So it's here. It's just breaking down by file. So for example, we could filter these by the location, the severity or priority of, and whether or not we flag them as fixed or not fixed. So for example, we'll just look at this one here. Oops. Sorry, so just click on that again. So we look at this one here. We can see here that it's flagged this particular file, this backlog workflow timer.esql, and it's flagged a couple of issues with this particular file. So there's no default broker schema used, which is one of those things you can set within the property file when you run the analysis. There's no header. The file is empty, which is should have been the case. The file's not really doing anything and possibly or should be deleted just because it's confusing. And the header is not contained in the file. So that means that in your setup, you've said that every file should contain your company name in the comment block, and this one doesn't. So it's not conforming to your standards. Now to run this, we'll show you two ways of running SonarQube. Depending on the type of project you've got, you can run it through your build. In this case here, I'm using something called Sonar Running, which I'll just run. So this is just running something called Sonar Runner, which just pulls down the components. It connects to Sonar, pulls down the components it needs, and runs those checks against your code. So it's pretty simple to run. So we're going to finish the analysis, and then at the end of this, it's going to run something called the build breaker, which is to do with the quality gate. So the build breaker says check the quality of this particular build, and if the quality is low, mark the build as incomplete. So what that means, what this means is for our Sonar setup, we've got this thing called a quality gate. And this is a bit of a contrived example, but it's just an example. So what we're saying for our project, we're analyzing, we've got a quality gate that says if you've got more than 10 critical issues, or you flag a warning, and if you've got more than 20 issues, you break the build. So we go into our analysis. We can see that it's been run. And you can see there's a big X on it, and when we go into our project, we can see there's a big red mark on the critical number of issues, and we can see that there's a big red box saying that the build broke because of the quality gate failed because the issues are not greater than what our allowed threshold is. So what that means is that we can apply a profile to some code with a quality gate that says these are the issues that are important, and this is the minimum or the maximum number of issues that we will allow before we let this software go out. What that means for running under Jenkins is if we had a continuous build environment where, for example, constructed our job to do our checkout, our check of our quality, our build, our deploy, and potentially some regression testing. In our configuration, I said this is just my local one, so I haven't got all the SCM, but you'd most likely set up the poll SCM to say you want to check a certain amount of time, to say every 20 minutes to see if a developer's made a code change. If they have, we're going to run this build, and part of this real build, we're going to run Sonar as a quality step using this particular Sonar runner. When we run our Sonar, when we run our job, or when Jenkins runs our job, because this has been a configuration change, we see our job appear. Well, we can get to our output, we can see the same analysis being run. It's basically checked our file, checked our code, run our analysis. We're running our analysis. And the same output broke it, where it says I failed because of my quality. But the difference being here, because we're running in a Jenkins sort of in a continuous environment, continuous build environment, we've actually flagged the build as broken, and we haven't continued on with the rest of the steps. So if this was the first step in a release process, then we would have not actually be releasing this software out. And so you'll be able to set up and configure on this job a notification chain to say post-build actions, email notifications. Your post-build actions would be sent everyone an individual. So sends the person who broke the build because of the code quality an email, and potentially said the release manager an email and the delivery manager an email to say that the code is not releasable at the moment with what was the last checked in, and that the person is fixing it, or that the person needs to fix it. That way, we're always getting a continuous sort of review of our code, continuous inspection of our code as developers check it in and features are delivered. Just quickly check if there's any questions. No? Okay. So the last part of our webinar is something called the diagramming component, so which is just configured using the properties file, just default directory. So the diagramming component is sort of a add-in that we've created for the plugin, or an extension for the plugin, basically that helps us understand our message broker projects better. So it helps us understand it diagrammatically from what we understand about your code based on what we've done already to analyze the project. So what I've got running here is just a fairly simple Mongoose web server, and I'm pointing out the generated code. So ideally you generate this code from your build server into some sort of common location, potentially Confluence, potentially something else where everyone can see it. That way that people can see what the status of the project looks like. So a lot of teams start with architectural diagrams about what the business logic of the solution might look like. So the intention of this tool is to try to reproduce an architectural understanding for the team, so that they can look to see if it does what they're expecting. So in this case here, we can see this is an integration of all the different flows within the system based on input and output queues. So for example, here we can see that this particular message flow consumes a message from something called the in queue, but nothing in our system that we can identify writes to that in queue. So it doesn't mean that there isn't something else running into the in queue, but we can't identify where we can't identify a message broker, data power, or Sterling component that's writing to it. This one here is a circular reference, so we can see here we've got a message flow which writes to a queue, DC, but it's the same queue that it reads from. So this might potentially be an architectural issue, the fact that it's reading and writing to the same queue, but it's something that it might be intentional, depending on what the flow is intended to do. It might be some severe processing flow or something. And we'll look at some of the other flows. We can see here, oops, this particular one consumes messages from two different flows. So this one here consumes from via QA, and then does some processing, sends it out to another flow via QB. So this gives an idea of how our different business processes or flows within our application work together. So in theory, you could give this diagram to someone in production support or someone in the business, and you could explain to them this is an overall sort of solution outline of the processing and the set of steps and the sequence of actions that's happening in an application. Now the other part of the diagram component is just summary, architectural summary of different things. So in this case here, we're looking at a summary of all the flows and the documentation we've got about that we can find about them. So we can see here there's some comments on this, comments and notes on this flow, either from the comments or from the notes. And we'll just put them all together, just to give you an understanding of what them, to give you an understanding of what the different flows are doing based on the comments that people have put into the flows. Queue summary, so a summary of where all the queues are used, which flows they're used in. So we can see QA is used from a bunch of different flows, an indication of where it's used from, whether it's Message Broker, Data Power, or Sterling Integrator. Now SQL statements can be quite useful. So this is where we've extracted out. So when we've checked tables and columns, this is where we've taken that information to check out tables and columns, and what we've done is we've tried to reproduce what the SQL would look like from a database perspective. So this is something that we can take to our DBAs, or our DBAs can keep an eye on, that gives an indication of what the application developers are trying to do with the database. So what this means is in DBAs have certain tools already that give you an indication of what's running, what SQL might be performing, whatever SQL through query plans is hitting which particular indexes and whatnot, which is useful. But this comes from the other side. It tells you what SQL is potentially going to run. So it's quite possible some of these things don't run very often. So this is something that you and the DBA as a developer can look through, and you could be looking at this from a point of view of a development environment, to indicate for them to understand what the data access looks like, ideally to help improve the SQL being written. Data source, just a summary of different data sources and where they're used in the application. Same with all the properties, so all the promoted properties, and where the default values are. So some timeouts and things like that. This is a summary of all the common SQL that we can find, or the SQL we can find. So this would be looking to be some sort of help you building up or documenting the common libraries that your applications may be using. So ideally, developers should be looking in here for code that does things before they go looking at writing their own versions. Summary of the Java methods, summary of the stored procedures, summary of all the monitoring events, which is none. Summary of all the input MQ files that the system reads. So if you know that this particular file name has been put somewhere, then you can see what actually is reading that file. If you know that there's a particular file being produced, then you can work out what's actually producing that file. A summary of all the URLs that the Message Broker is producing, so all the things, SOAP and HTTP services that Message Broker is providing to other components, either internally or externally. Output URLs, so these are all the external components that Message Broker is calling out to. So we can see here that this particular timer flow is actually calling out to using a HTTP request to go to this test address server on this particular port. Summary of all the exceptions in the system and a little bit of and then documentation of the description. So this helps just to get these things consistent. And then you've got the data power input and data power output, process locks, and some Sterling specific facts, I guess you call them. So that's the end of our webinar. So hopefully you've learned a little bit about SonarQube and Jenkins, whether or not it's going to be applicable to your Message Broker development, but hopefully it's some food for thought for any other development you're using, where you might want to look at the quality of the code. We've looked at coding, we've looked at continuous code inspection and how we can build a basic quality process using SonarQube and Jenkins, or potentially any other build server that you use, say TFS or Bamboo or any of those products. And we show you how you give that feedback loop of breaking, using the build breaker to break the build and give feedback to the developer when the code quality drops. And then we've done the quick demonstration around the violations and the metrics and the diagramming that's specific to the MB Precise plugin. So if there's no questions, I will let everyone get on with their day. Hopefully enjoy your Friday, and thank you for joining us. If you do have any questions or have any thoughts, our website is www.bettercodingtools.com, and please feel free to use the contact page to email us. Again, thank you for joining us.